Okay, in previous session we have discussed about system properties. Now here we will solve some of the examples in coming 2-3 sessions where some problems related to various properties like time invariance, linearity, causality, dynamicity, invertibility and all. So here first of all let us have some examples based on a time invariance property. So we want to check whether the respective system is time invariant or not. So this is first one, y of t is equal to e raised to x of t. So what you are supposed to do is, first of all you write down the expression and let us name it with some label as 1, 2 like that. Say for example, instead of yt, now I am naming it as y1t. Accordingly I am naming the input signal also as x1t. So my system equation is y1t is equal to e raised to x1t. Now the new input I'm going to apply, which is a shifted version of earlier input. So new input I'm naming as x2t, which is equal to x1 of t minus t0. So this t minus t0 is indicating time shift. Now the corresponding output will be y2t is equal to e raised to x2t. Now instead of x2, now we want to substitute this x1 t minus t0. So therefore I have written here x1 t minus t0. So our system equation is becoming y2t is equal to e raised to x1 into t minus t0. Okay. Now just next part. Now y1 t minus t0. So output side we want to shift. This is input side is finished. Now output side y1 t minus t0, which will be equal to e raised to x1 t minus t0. And now if we compare this e raised to x1 t minus t0 with the above equation 2, that is which is corresponding to y2t. So since right hand side e raised to x1 t minus t0 and here also e raised to x1 t minus t0, and therefore y2t is equal to y1 t minus t0, and this is indicating that system is time invariant. Now next one. Say discrete time system is given, yn is equal to xn x of n minus 1. Now let x1n be the input and respectively the output is y1n. Now y1n we will write as according to the expression given as a system equation. So it is x1n into x1n minus 1. Now second input x2n we will give, which is a shifted version of x1n, that is we are shifting input. So therefore x2n is equal to x1 of n minus n0. Now y2n is equal to x2 of n minus n0 into x2 of n minus n0 whole minus 1. Because we need to substitute here n is equal to n minus n0. Now suppose this same n minus n0, if we substitute in our original equation, that is y1n is equal to x1n into x1n minus n1. So we can write here y1 n minus n0 is equal to x1 n minus n0 into x1 n minus n0 minus 1. So what we are doing is, here we have first done shifting of input and now here we have done shifting of output. And if we compare equation number 2, where y2n is equal to whatever right hand side, which is same as equation number 3, y1 n minus n0 is equal to same thing. So comparing these two, since the right hand side is equal, therefore left hand side, that is y2n, must be equal to y1 of n minus n0, and that indicates that system is time invariant. See, procedure is simply, first of all, in the input side we are going to change t by t minus t0, and if it is discrete time then n by n minus n0, and we are only writing the terms in the form of the given interpretation, nothing we are doing. But here what is happening you can see. So inside bracket we are supposed to change it, and one case is directly we are shifting input and another case is simply we are substituting t wherever it is by t minus t0. These are the two things which we are doing. Now see here, equation is y of t is equal to t into x of t. So y1t is equal to t into x1 of t. Now the new input x2 is equal to x1 of t minus t0. Therefore y2 is equal to now t into x2 of t minus t0, because wherever there is x1t there only you are supposed to now write x2t. So this t is remaining as it is. And now if suppose in the equation 1, which is basic equation, wherever there is t, if we write there t minus t0, then our equation will become y1 t minus t0 is equal to t minus t0 into x1 t minus t0. Now if we compare equation number 2 with 3, then what is happening? Left hand side is y2t here, but it is t into x2 of t minus t0, and here y1 t minus t0 will be equal to t minus t0 into x1 t minus t0. Now you may have a doubt that here why you have not changed this t, why you have kept this t as it is. See here what we are doing, whatever is our input, that only we have changed to t minus t0. So therefore wherever there is an input term, there only we are going to make it x2 t minus t0. This t is outside that, so it is playing no role. But in the other case, when we are making output shifted version, so basic output equation, that is getting affected by this t, and instead of t now it is becoming t minus t0. So therefore here also we need to change t by t minus t0. We have to replace it. And therefore this equation and this equation, here only input is getting affected, that is a shifted version. But here output is also getting shifted version, but in accordance with this t term, now that has also become t minus t0. So instead of t, it is t minus t0. And therefore these two are not equal. Equation number 2 and 3 are not equal, and our system is not time invariant. System will remain time invariant only when your domain t is inside bracket. It is operating domain. If it is coming like this outside, then definitely this will create a problem, and the sudden changes at the input side in the domain, whatever is happening, they will not get exactly followed by the output at the other side, and that's why it is not time variant system, but it is not time invariant system. Now next is same fashion, x of t into sine of 10 pi t. So we are going to make it x2t. First of all, y1t is equal to x1t into sine of 10 pi t. Now x2t is equal to x1 of t minus t0. Now y2t is equal to x2 of t into sine of 10 pi t. y2t is equal to x1 of t minus t0 into sine of 10 pi t. Now if we substitute t is equal to t minus t0, then y1 t minus t0 is equal to x1 t minus t0 sine of 10 pi t minus t0. Here also this term is not matching with this. So equation 2 and 3 are not equal, and therefore system is not time invariant. Now next is y of n is equal to x of n by 2. Same style, though it is a discrete time. y1n is equal to x1 of n upon 2. x2n is equal to x1 of n minus n0. Therefore y2n is equal to x2 of n by 2. y2n is equal to x1 of n minus n0 by 2. And now substitute wherever there is n by n minus n0. So y1 of n minus n0 is equal to x1 of n minus n0 by 2. And since equation number 2 and equation number 3, you can say that you are getting time invariant system. So here I have written system is not time variant, that is it is invariant. Now here you can see yt is equal to t square x of t. So same fashion, x2t is equal to x1 of t minus t0. y2t is equal to t square into x2 of t. Instead of x2 of t, I will write x1 of t minus t0. This is one equation. Now if we substitute t by t minus t0, then y1 t minus t0 is equal to t minus t0 bracket square into x1 t minus t0. So this term, equation number 2 and equation number 3. So this is shifted version of output, which is not same as the only output which is obtained because of input shifting. So therefore system is time invariant. Here it is x square n minus 2. Same y1 n is equal to x1 square n minus 2. New input is x2n, which is equal to x1 of n minus n0. Therefore y2n is equal to x2 square n minus 2, and y2n is equal to x1 square n minus n0 minus 2. So if we substitute it, same equation we are going to get if y1 is n minus n0 done, and therefore system is time invariant. The reflected version, then also it is the same effect. Yt is equal to x of minus t, y1t is equal to x1 of minus t, x2t is equal to x1 of t minus t0. This is shifted version. Therefore, y2t is equal to x2 of minus t, which is equal to x1 of t minus t0. So, t minus t0 if we substitute, then y1 t minus t0 is equal to x1 minus into bracket t minus t0. Therefore, it is going to become x1 of minus t plus t0. And if we compare, system is time variant. Okay. Now it is, say, differential equation. So here coefficients of differential equations are constants. So otherwise there is only in the domain t is as it is following everything. So therefore system is time invariant. Now we want to check whether the system is causal or not. So some simple equations you can see here. Yn is equal to xn plus 1 upon x of n minus n0. Now suppose we write for n is equal to 0. Then y of 0 is equal to x of 0 plus 1 upon x of minus 1. Then n is equal to 1. Then y of 1 is equal to x of 1 plus 1 upon x of 1 minus 1, that is 0. N equal to 2 is then y of minus 1 or n equal to minus 1, say for example. Then y of minus 1 is equal to x of minus 1 plus 1 upon x of minus 1 minus 2, that is x of minus 2. So output depends on present and past values. You can see here these are all past values. N minus 1 corresponds to past values, and therefore we can say that system is causal. Because for causality, what is the condition? The output should depend on present state or past state, not on future state. Now here it is x square t plus x of t minus 2. Since only t and t minus 2. So this corresponds to, t corresponds to present state and t minus 2 corresponds to past state. So therefore system is said to be causal. Now y of n is equal to x of minus n. Now we put n is equal to 0, y of 0 is x of 0. N equal to 1, y of 1 is equal to x of 1. N is equal to minus 1, y of minus 1 is equal to x of minus minus 1, that is x of 1. N of minus 2 is equal to minus 2, it gives y of minus 2 is equal to x of minus 1 minus 2, that is x of 2. So this is how it is becoming minus of minus 2, that is plus 2. So for negative values of n, output depends on future input. You can see here, these are the negative values of n, but the output depends on the future input, and therefore we are calling it as system is not causal. Now y of n is equal to x of n square. Simple, n is equal to 0 and n is equal to 1. Output does not require future value of input. So for n equal to minus 1, y of minus 1 is x of 1. Output depends on future value of input. For n of minus 2, y of minus 2 is equal to x of 4. Again output depends on future values. So here we can say that system is non-causal. So therefore for 0 and 1 that is okay, but for minus and 1 minus 2 system is not remaining causal. Then y of t is equal to x of tau d tau minus infinity to 2t z of t. Now for t is equal to 0, y of 0 will be minus infinity to 0 x of tau d tau, which is equal to z of 0 minus z of minus infinity. Then t equal to 1, y of 1 is equal to minus infinity to 2 x of tau d tau. So it is going to become z of 2 minus z of infinity. So y1 depends on z of 2, that is future value. So here this is future value, this is 1 is current value. So therefore the system is said to be non-causal. Now y of t is equal to x of t minus 2 plus x of 2 minus t. Say for example t equal to 0, y of 0 will depend upon x of minus 2 plus x of plus 2. So this is indicating future state. This is indicating past state. So therefore output depends on future state as well as past state. Since future state is involved, the system is said to be non-causal. Now say for example there are some expressions where we want to check whether the system is dynamic or not. Dynamic stands for system with memory. Static stands for system which is memoryless. Now if there is in the output equation some past term or future terms are included, or it involves such terms, then definitely system will be dynamic in nature. But if output depends only on the current state of input, then the system will be purely static system. Now see here, for example, first one, y of t is equal to x of t minus 2. So output depends on past state of input. This t minus 2 is a past state. So therefore system is said to be dynamic. Y of n is equal to x of n plus 2. Output depends on future input. So system is said to be dynamic. Y of t is equal to x square t. So output depends on current time. System is static. Only current time is involved, though it is a square operation. Y of t is equal to d2yt by dt square plus 3 dt, 3t ddt of yt and yt, which is equal to xt. So system is described by differential equation and therefore it is said to be dynamic. If it is y of n into cos of x of n, so output depends on input at the instant only, and for that instant only, whatever is value of n, its value will be written as output. So therefore it is a pure static system. Then y of n is equal to log of x of n. So here output depends on input at that instant. So system is said to be static. Only xn term is involved. Here also only xn term is involved. So it is instantaneous. So that's why it is said to be static system. So in this session we have seen some examples related to time invariance, causality and dynamicity. Now in one more session we will go for some sort of other properties associated with systems. Thank you.